No, that's my least favorite part of any game.
Carl,
That part.
Dr. Carl Isaacson, he's the moderator for this session.
Are you unmuted?
Hello.
Balloon race.
Go ahead and turn the volume down.
Insane. It took me like a half hour to get them.
Go ahead. Go ahead, Carl.
Hello. I'm Carl Isaacson. Can you hear me?
Yep.
All right, so let's get started if that's what I'm hearing. So our first speaker for this morning's session is Joe Poeppel.
Poeppel.
Poeppel from University of Minnesota Twin Cities, and his title is Minnesota Space Grant Intercollegiate Challenges and Competitions.
Perfect. Thank you, Carl. Let me share my screen.
Just ask Carl if he can hear you okay.
Okay, Carl, can you hear me okay if I'm right here? Carl, can you hear me if I stand right
Yes. Yep,
Okay,
I can
perfect.
hear you fine.
here? Perfect. Okay, hi everyone. My name is Joe Poeppel. I'm a senior in aerospace engineering here at the U. Most of you guys are on Zoom, so try to talk to the camera. So today I'm just going to talk about some of the Minnesota Space Grant challenges and competitions that are put on each year. So just to give you a quick overview, first I'll talk about the Midwest High Powered Rocket Competition. Next I'll talk about GLEE, how that transitioned into Gleam, and now is the Gleam Lunar Robotics Challenge. And then I'll talk quickly about the Quadcopter Challenge, and then just update you on future competitions and challenges. Personally, I have been involved with the Midwest High Powered Rocketry Competition as one of the University of Minnesota rocket team's leads, as well as on the team years before that. And then for the Gleam Lunar Robotics Challenge and the Quadcopter Challenge, I haven't partaken in it directly, but I was involved with developing the firmware and hardware for these challenges. So to give you a quick overview of what the Midwest High Powered Rocketry Competition is, I'll kind of go over some of the competitions for the years past. So starting in 2014, 2015, it was a boosted dart. 15 to 16 was air brakes. 16 to 17 was flying to the same altitude on two motors as different as possible. 17 to 18 was roll control. 18 to 19 was an efficient supersonic rocket. 19 to 20 was a photography altitude challenge. And then this year is the return to flight. So as you can see, these challenges do vary drastically from year to year. Just because we're limited on time, I won't go into specifically what each one really involves. However, if you have questions, feel free to email me or Dr. Flatten, and we can explain them more. But for this year, because of COVID, there was a good 2-year gap of any flights. And so this year's competition is essentially building a bunch of different rockets, try to make them all as different as possible, just to kind of get back in the groove for teams that don't do high-powered rocketry so often. So it gives them good experience to build a whole bunch of different rockets, and then they have a good foundation going forward for next year's competition. So just to give you an idea of the magnitude of these rockets, they're much bigger than what you would normally buy at like Hobby Lobby. They use much larger total impulse motors. So that's just a good picture to kind of put it into perspective for you. So not only does the competition require you to build a rocket to meet some set of design challenges, however, there are also a lot of technical documents. And so you have to do a critical or preliminary design report, a critical design report, a flight readiness report, an oral presentation, and a post-flight report. In any career that you go into, being able to communicate your words and your thoughts on paper is very essential. But even more than that, you get great feedback from a panel of judges for these reports, so that you don't just go and build a rocket and then come the day to fly it. You're not allowed to, because it's not safe. So it's just a great way to be able to communicate your ideas, but to make sure that you will be able to fly on launch day. And then lastly, the competition does require you to do a test flight. And test flight's not only great to confirm your design, make sure everything is working as expected, but it's also a great skill to be able to take limited data that you have and be able to figure out what went right, what went wrong during a flight, and what you need to change from that. Sorry. Okay, so personally, coming in freshman year, I didn't know anything about high-powered rocketry. And by working with a upperclassman, by the end of freshman year, I was able to help him design a custom printed control board, which was used for integrating commercial altimeters that are required for the competition with custom avionics to be able to get camera footage, get GPS, but most importantly, determine how fast and how high a rocket went, which is a key part of most of the challenges. We've got two fun videos. So this is the efficient supersonic rocket, which I have sitting here. And the goal of this rocket was to go as high and as fast as possible on one flight. Then you could change the nose cone and the boat tail, and then you had to hit supersonic underneath the lowest altitude as possible. So this first flight is the as high and as fast as possible flight.
When you shared your screen, you didn't share your audio. That's okay.
No, I did. It just. And then this is, sorry, this is the supersonic flight on the right. So much quicker. So the first flight went to 7,000 feet, hit Mach 0.7, and the second flight went to 5,000 feet and hit Mach 1.2. So we actually ended up winning this competition with this rocket, so that was very exciting for us. So where the Midwest competition can lead to is mostly, or usually, the Spaceport America Cup competition. This rocket is much larger. Right now, our current design here at the U is about 16 feet, 230 pounds. So obviously much bigger than the rocket I brought here today. But these rockets typically use a lot of the same design aspects that are used in Midwest. For example, in this rocket, we do have roll control, we have air braking, we have custom avionics, and we also have an air data system with the Torpedo 2, all of which were integrated in some way in a past Midwest competition. Moving forward is the Gleam Project. So the Colorado Space Grant is putting together this project to send 500 of these small Lunasats to the moon. And of course, this is very expensive, takes expensive hardware to do. And what we wanted to do here at the U was make this more of an educational foundation and something we can do in a classroom. So Dr. Flatten and I were able to come up with the Gleam Project, which is essentially a spinoff using cheaper components with breakout boards. And so we had a class full of 20 people with these Gleam units with the central unit. And the goal was to be able to put these in some unknown environment and have all the data sent back to the central unit, similar to the Gleam Project. And so this year's, I guess here's an example of that data being sent all to a ground unit. And this year's competition is to do that, but make it mobile. And so essentially each team was given a Gleam unit. They could either use that or make their own, put it on some type of robotic system to move them around in unknown terrain to be able to figure out, kind of what their environment is without actually being.
Joe, you're starting to run out of time here.
Okay, I know, I'm trying to go quick. This is the last one. And then in the years past, it was a quadcopter challenge. Essentially, they were given a drone and a kit drone, learn how to fly the drone, and then use this kit drone to integrate some sort of avionics sled onto it to be able to navigate an unknown terrain via flying, rather than this year it's on some sort of ground vehicle. So some future challenges and competitions. The Midwest competition is typically announced in September 2022 is when it's predicted to be, and the Minnesota Space Grant, the Intercollegiate competition, is in October 2022, hesitant. If you want to reach any of us, here's Dr. Flatten's email, my email, and then if you have access to these slides, the links for each synopsis of the challenges is posted there. Sorry, that was a lot. Very quickly, I did my best. Do you have any questions?
Does anybody have any questions for Joe?
I have a question. Can you hear me on Zoom?
I can hear you on Zoom.
The question is, of the things you mentioned, which will be on display today?
Yep, out of all the, actually all of them will be. Sophia will be having an exhibit about a lot of the rockets for this Return to Challenge flight. And there'll also be an exhibit for the Gleam Project, as well as the lunar robotics. So, and Glee. So there's a lot of exhibits. So I don't want to steal too much thunder, but feel free to go down to those exhibits and check those out.
Bethel will be doing Midwest this afternoon.
Okay.
We're not doing quadcopters. That's a couple years
Yeah.
old.
And then there are also, Duluth will also be talking later today during one of the talks about the Spaceport America Cup competition specifically.
Are there any other questions? If not, we're running up to the time limit. So thank you, Joe.
Yep, thank you.
So, Paul, you have to stop the recording? Stop the recording again? I will
Sure.
get the next recording for the next speaker.
Carl, remind me, who is the next speaker?
Next speaker is